Hey, you awesome pre-calculus kids. This week we'll do the 6.5, but there's only two questions in your assignment, so it's not bad. And then there is a quiz over 6.4 and 6.5, but again, just two questions. So you should have a pretty decent week. This linear optimization may look confusing, but it's really not that bad. Linear programming is a process for finding a minimum or maximum value for specific quantity. Just to let you know, for the assignment, actually, I don't know about for the assignment. I know for the quiz, you just have to find the maximum value. Okay, so I'll kind of point those out to you. Fundamental theorem of linear program, the maximum or minimum value of the objective function in a linear programming problem is achieved at one of the vertices of the feasible set. Basically, you're going to be giving equations for these lines, and then also this line and this line, and it's going to create this area in here. And we're going to test each of the vertices to see what gives us the maximum value or minimum value. So the point that yields the max or min value of the objective function is called an optimal point. So here's kind of the steps for doing this, and then I'll do a couple problems with you. To solve a linear programming problem, you need to graph the region corresponding to the solution of the system of constraints. And the constraints are the lines, the equations of the lines. And then you need to find the coordinates of the vertices. And then you just need to evaluate the objective function, which they give you that at each vertex to determine which x and y values are the highest or the lowest. Okay? So this will make way more sense when we do one or two. So this example says, find the maximum and minimum values of the objective function, and we have given that right here, and for what values of x and y they occur, subject to the following constraints. So what we need to do is take these equations and graph them and find our feasible region. So you have to remember how to graph lines. That's all there is to it. I like to start with the x's and the y's first because those are just your axes, usually. So when y is greater than 0, it's going to be this line right here. Wow, I think I should Control Z that. I should probably use actual lines. Might be a little bit nicer. Okay, I'll kind of make those. And then when x is greater than 0, it's going to be let's see if I can put this in here. Here we go. The y-axis. So basically we have this area here, the first quadrant, and you're going to see that they're all pretty much going to be in the first. Well, that's not true. Never mind. I was going to say all of them are in the first quadrant, but I'm pretty sure my next example isn't just in the first. Okay, so I graphed x is greater than 0. That's my vertical line, my y-axis. My y is greater than 0. That's my horizontal line, my x-axis. And then I have x plus y is less than or equal to 5. So I'm just going to put these into slope-intercept form. So which is y equals mx plus b. So I just need to subtract x. So I got y is less than or equal to negative x plus 5. So 1, 2, 3, 4, 5. And then down 1 to the right 1, down 1 to the right 1. And I will find myself okay, that'll have to be close enough. And then with the 2x plus 3y is less than or equal to 12, I'll do that over here. I'll subtract my 2x and divide by 3. Okay. So this is going to be a plus 4, and then down 2 to the right 3. So I'll stick in a line there. Okay, you should be able to see then, if I shaded this, which I'm not going to try to guess how to do that right now, but if I shaded this, I would have, oh, I'll just highlight it, this area in here. But what we care about are the vertices, and you can see here we have one vertex here of this region in yellow, one here, and one right in here. I'll have to check and see. Oh, I think it was this point right here. Okay, so you need to pick out those points. Well, this one's 0, 0. This one is 5, 0. This one is 3, 2. And 0, 4. Those are kind of your critical points. And you're going to plug them into this equation, the 2x plus y. So when I plug it into the 2x plus y, I put a 0 in for x and a 0 in for y, I get 0 out. When I plug this point in, I get 10 out. When I plug this in, I get 6 plus 2, I get 8. And when I plug this one in, I get 4. And these are just the numbers that you use. You find, to find the maximum, you look at the biggest number, right here. To find the minimum, you look at the smallest number, right here. So this is my min, and this is my max. That's all we need to do is, if they're asking for the min or max, just which coordinate point. So like I said, on the quiz, I'm pretty sure I just asked for I actually asked for the value of the maximum. So you would give me 10 for the answer in that case. Let's try another one. All right, this one, you have your objective function of f of x comma y equals 5x minus 6y. And then here's the constraints. So there's only 3 here. Now you can have a lot, okay? You could have 6 equations there and have some crazy looking thing. You could have 10 equations. You could have just 3. Okay, so let's do this. Y is less than or equal to 6. So that's going to be a vertical line, or wait, a horizontal line. At 6, I'm going to insert a line. I don't know how long that has to be. Okay, and then did that just change color? Oh, crazy. Okay, so y is greater than or equal to 2x minus 2. That's already in slope-intercept form, so let's go to -2 and then up 2 to the right 1. And I'll draw myself a little line. And the last one, oh, we have to go down to -12. 2, 4, 6, 8. I gotta make a little mark at 8. 10, 12, okay. And, whoa, why did it do that? It's wacky. Apparently, okay. Does that one stay? Oh, what the world? Okay, so I guess I will just see what this is. -3. So if this is my 12, yeah, 2, 3. Oh, that's so weird. It's like moving the wrong, I don't know. Holy. Okay, well, I'm just gonna keep going here. Okay, I don't know what was wrong with it, but I got the correct points and kind of a line drawn here. So you can see that the feasible area is going to be, well, let me put it back on pen here. Is going to be this area in here. Okay, so we have our points, our vertices right here, and right here. So there's just 3 of them we have to worry about right now. So 4, 1, 2, 3, 4, 5, 6. So I have 4, 6. I have 1, 2, 3, 4, 5, 6. I have -6, 6. And I have -2, -6. All right, we need to put into my objective function, my 5x minus 6y, and I'll put each one of those into that. So 5 times 4 is 20, minus 36. I believe that's -16. It's been a while. 16. I have -30 minus 36, and I get -66. And then I have -10 plus 36, and I get 26. So those are my min and max values. So here's my min, because that's the smallest value, and here's my max, because that's the largest value. So just, you'll need graph paper most likely so that you can get exact vertices, and I picked ones, I believe, where they're on a point, so that it's not too super tricky for you. But if you ever come across 2 lines where they're not on a point, so where they meet, you're going to have to just solve it like a system of equations. Just pick those 2 lines and solve it, set them equal to each other, whatever you need to do. But these are the points, and then you just plug them into your objective function, your x and your y, see what you get, and pick out the min or the max. That's about it. Good luck.